Hello. Okay. So in today's session, we are going to see uh, message formats. Okay. Message formats that pass between different components of fabric network. Okay. So in previous session, we have seen in any fabric network we will have a client who will initiate the transaction, and then we will have a organization and that will host a peer, right? And then we will also have a orderer. Okay. So say suppose these are three components, and I will not today make this diagram very complicated because we have understand the we have understood the transaction flow. Today I will explain you message formats. Okay, so for that I just need one peer, one orderer, and one client. Okay, so let's start. This is my client, and this is peer, and this is our orderer. Okay, so and further, this peer will have it will have a ledger, right? And the ledger is consist of two components: state database and uh, another database kind of structure that holds your transaction records or transaction history. Okay, so this is my ledger. Okay, and all peers, and actually your order also contain a ledger. Okay, now say suppose your client initiates a transaction. Okay, invoke transaction, not the install transaction. Okay, or deploy transaction. It initiates a install transaction. Oh, sorry, invoke transaction on a particular chain code, and obviously, um, sorry, peer will also have a chain code. So now say suppose Now, say suppose your client initiates a transaction, and obviously your client first have to send the transaction to the peer for the endorsement, right? Okay, so this is my endorsement request or the proposal, endorsement proposal. Proposal. Okay, and this endorsement proposal is sent by your client. Now, what is the format of that endorsement proposal? So, what is the format of this endorsement proposal? We are going to see that. This endorsement proposal is consist of two parts. Okay, first there will be a header called the proposal. Okay, and then proposal will contain a transaction and it will have a anchor. Okay, now let's first understand what is the anchor. Okay, anchor is anchor is nothing but version number. Okay, so in previous session I explained you uh, in ledger, in the state database, your keys are versioned. Each key is associated with a value, but each key is also associated with a version. Each time chain code updates a key through a transaction, version number of that key gets increased or gets updated. Okay, now say suppose your client want to use a specific version of for the read set. Okay, then uh, client can use this field to specify the version number. So when your transaction will be simulated on the endorsing pair will use this version of keys for for the read values, to read values or to get the values from the ledger for the simulation. So if you want, or if the client want to use a specific version for the read set, or to a specific version of keys against which he want chain code to execute or simulate the transaction, then that version can be specified here. Okay, next we have transaction. Okay, transaction is uh, consist of, okay, client id, chain code id, transaction payload, timestamp, and client signature. Okay, so this second part, transaction TX is consist of transaction client ID. So in the first portion of transaction, your client proposal message will contain the transaction ID. Oh, sorry, it will contain the client ID. Okay, so transaction this TX is consists of client ID, which is the first part. Okay, so this is the client ID of your partner who is initiating the transaction. Okay, then the chain code ID. Chain code ID is the string that uh, that your client has to know which on which chain code he want to execute or send this particular transaction. Okay, when we deploy the chain code, we specify this chain code ID, right? In our example, okay, in our example, system is a little slow today. Virtual machine is not running properly, I think. Okay, so if you see here, we always use the chain code ID like this. So in our case, chain code ID is J channel. Okay. Oh no, no, this is chain code ID. Sorry. Okay, this is chain code ID, and I have used the same thing when uh, I when I'm adding something on the ledger, when I'm initiating a transaction to update the ledger. This is my chain code ID, and this is how I have created the chain code ID that I passed in the transaction proposal, right? So basically, this is the set name determines your chain code ID. So in my case, chain code ID is hello world. Okay. Next is your transaction payload. Okay. Transaction payload is nothing but method name which you want to invoke or function name which you want to invoke on the chain code, and the parameters that you want to pass to your chain code. Okay, so this transaction ID will consist of two parts. One is function name and metadata. Okay, so function name is the name of function that you want to invoke on the chain code, and the metadata is nothing but parameters that you want to pass to your chain code, right? In our case, this is invoked, and these are the parameters that will go in the metadata portion, and this will go in the operation part. Okay, so this is your transaction payload. Then we have timestamp. Timestamp is when your client initiates the transaction. And the last, which is very important part, uh, of your transaction proposal, is client signature. Okay, which is your client signature. So every transaction, right, between the component of blockchain has to be signed. Okay, so your client has signed the transaction. Okay, and in this portion of your in the last portion of your transaction proposal, your client has to specify the his signature. Okay, now I hope you understand what is the signature. Okay, what is how we create the signature, and how basically it work in the uh, public private key infrastructure. Okay, so basically your client has to create a he has to create the uh, hash value, or calculate the hash value of the transaction, and then he will encrypt that hash value with his private key, right? And we call that encrypted value as a signature, on very high level, if you're not familiar with. Okay, and there will be a lot of other technicalities involved in this, but if you want to just understand it on very high level, then this is how you can understand the signature. Hmm. So your client will calculate the hash value of your transaction, and then it will encrypt that transaction, right, with the private key, with his private key, right? And this uh, and we call that encrypted value as a signature, right? This signature will be sent to the other party, and your other party has public key, right, or the certificate that is corresponds to your private key. Then he will able to decrypt that encrypted message. Okay, and if he successfully encrypt it, and he calculates the hash value of the same transaction, and hash value of transaction that he calculates, and the decrypted value of your signature, if matches, then we call that your other party will assume that transaction is your signature is valid, your signature is verified. Okay, so in this last portion, your client sends his signature. Okay, so this is the format of your proposal. So in proposal, we send these informations to uh, your endorsing peer. Okay, now we have signature. Okay, your endorsing peer, this peer will uh, okay, so your endorsing peer will now first verify the format of the proposal, right? So it will check if it has your transaction has all these parameters or not. If it has all these parameters in a specific sequence that he likes, then he will consider this proposal as a well formed message. Okay, Then obviously in the next step, you know that now client has sent the signature, client signature, right? So it will use this client signature, right, and validate if this particular client has permission to invoke a chain code, invoke a method on the chain code. Okay, so this is your authentication part. I mean the authorization part. Okay, and obviously signature is also signature will be also verified. Okay, so if your signature is verified and it peer has also verified that client has permission to invoke a method on the chain code, then your peer will simulate the transaction. It means it will invoke the method which your client want to invoke, and after executing the method, it your peer will not commit the updates on the transaction, right? We discussed this part in the previous session also. So it will just create a read write set. Okay, it will just create a read write set. Okay, and this read write set will be sent to your client. Now let's understand the format of your endorsed message or endorsed transaction. So your peer has sent endorsed transaction. Now this is your transaction. Now let's look at what is the format of endorsed transaction. Okay, okay. So format of endorsed transaction will be transaction ID. Okay, transaction proposal and endorsement peer signature. Signature. Okay. So it will have transaction ID. What is transaction ID? Transaction ID is nothing but it's a hash value of your transaction. Okay. So this is your transaction, right? So your peer will calculate hash value of your transaction. Okay. And this value is called as transaction ID. Okay. This is your transaction ID. Then we have transaction proposal. Okay. Now transaction proposal is consist of uh, endorsement peer ID, transaction ID, chain code ID, okay, read set and write set. Okay, try to understand this. Okay, so first value is endorsement peer ID. Okay, so this is your first value, endorsement peer ID. Next value is transaction ID. Okay, so I have explained you what is a transaction ID, right? After that, we have chain code ID, right? We know what is chain code ID because I explained you a moment before, right? So now you know the chain code ID. Next, we have read set and write set. Okay, so primarily, today I wanted to explain you what is the read set and write set because it's very important to understand. Okay, we know that when the transaction proposal was sent to the peer, it has not actually committed anything on the ledger. It has just simulated the transaction. Okay. Now, if your chain code, okay, reads any value from the ledger, okay, if it reads some value from the ledger, right, that value will become part of your read set. Okay, it becomes something like this for just for your understanding. Read set, okay, read key equal to init version equal to what? ABC version 2, something like this. This is your read set. Okay, means when chain code is executed or simulated by the peer, before it make any changes in the ledger, okay, or before making any operation in that method, chain code has read two values from the ledger. Okay, these two values that has been retrieved from the ledger will become the part of your read set. Okay, like this, int and abc. Okay, read in the read set, it will also capture which version of the key was read. Okay, uh, in the code chain, I mean in the chain code. Okay, which version of the key was read by the chain code. Okay, because it is important to capture here. Okay, because we have just simulated the transaction and we have a result. Okay, when it will be committed, it is very important that value of uh, read values of keys is still remains same when the ledger is updated by the committing peer. Okay, so let me explain you with an example. Like, for example, this. Okay, this is my invoke method. Okay, so this is where I'm updating my ledger. Okay, so I'm updating my ledger by put operation, stub dot put, and then my key, and this is the block, right? But before this, I'm also reading a value from the ledger, or I'm fetching a value from the ledger called the init. Okay, this init will become part of your read set. Okay, and when this statement is executed by the peer in the chain code, what was the version of this key in the state database? Okay, if the version was 2, then in the read set version will be 2. If the version was 5, then the in the read set version will be 5. Okay, so this is your read set. Okay, So read set captures version of keys that is fetched by the chain code in the chain code method. Okay, and because these are the values which your chain code method has used before uh, coming to any conclusion, before committing any value or updating or making any change in the in the ledger, right? So and these are the values and these are the version, sorry, these are the keys and these are the version of that key. Okay, so this is your read set. Now come to the write set. Write set. Write set. Okay, you know your transaction has been just simulated, right? It's not committed. So chain code creates the write set. Okay, write set will have all the keys that has been either added or updated or deleted by the chain code operation. Okay, write set will have all the keys. Okay, it will capture all the keys that has been either updated or added or deleted by the chain code. Got it? And format of this will be something like uh, it will be hello, something like this. Okay, so say suppose your chain code is updating two values, okay, or adding two values, or maybe updating one value or and adding two value, adding another value. So suppose first value is added and the second value is updated, right? So your write set will capture these two values in this format. Okay, so this is your read set and write set. Okay, now this in message. Okay, this message that contains read set, write set, and transaction ID and this endorsement peer ID will be sent to client. Oh, and one more thing, the last field that we are forgetting, but this is the most important field, is your endorsing pair signature. Right, this is very important. Right, so after the simulation, your peer will send the result of this simulation to a system chain code. Okay, your peer will send the result of the simulation to a system chain code, and this system chain code will, based on some logic, right, and criteria, it will sign the simulation result. Okay, it will sign the simulation result, right? Once that happens, we call it as endorsed proposal. Okay, proposal is sent, proposal has been simulated. Now it will be sent to the a chain code that is running inside the peer, and that chain code will endorse the transaction proposal by signing it, or by adding this signature at the end of the message. Okay, now that system chain code by default has a logic that just simply signed all the transaction proposals, right? But based on your requirement, right, you have to override that system chain code, right? You have to, maybe you will be doing some database checks or some business logic, and if that business logic satisfy, then only you want to endorse the transaction, else you do not want to endorse the transaction, right? So you will be doing all these operations in that system chain code. Okay, so by default the system chain code endorse everything. Okay, endorse everything means it adds the signature of endorsing peer at the end of the transaction proposal message. Okay, so this is how your endorse transaction proposal look like, or this is how it is consist of. Okay, now client receives this transaction proposal, and then it sends this transaction proposal to orderer. Okay, for the broadcasting. Okay, now you know that your orderer will wait for fraction of second, and it will group all the transactions that has come in that particular fraction of second, and then it creates a block, and then it sends that block to all peers, right? And one more thing here, something you need to note: your orderer actually does not open the transaction, it does not read the transaction. Okay, it just simply orders them and sends to all peers for actual update, or committing the values in the ledger for permanent change. Okay, so, and I have already explained you how it orders the transaction. Basically it calculates the hash, cryptographic hash of first transaction, right? And then it adds that cryptographic hash to the next transaction, in the next transaction, right? So each transaction will have cryptographic hash of next I mean the next transaction, right? And then it calculates the cryptographic hash of all the transaction, and right, and then it will make a block, right? And then that block, it will have cryptographic hash of all the transaction of previous transaction that was broadcasted by your orderer. Okay, so it will be something like this. Let's understand it again. Okay, so you have T1, T2. Okay, hash, cryptographic hash of this transaction will go in this transaction. Okay, somewhere here. Okay, so that way this transaction will be linked to this transaction. Okay, if you have another transaction T3, then it will calculate the hash of these and it will place in this transaction. Okay, so it will be linked to this. Okay, and then it creates one block, okay, that contains all these T1, T2, T3, right? And in the header of this block it will place a sequence number S1, okay, sorry, S0 sequence number, and it will also add the cryptographic hash of previous block that was broadcasted by this order on the channel. Okay, so say suppose hash previous hash of block was 1 2 3 4, so it will contain 1 2 3 and 4. Okay, and then this will be published to all the peers. Okay, this block, okay, which contains the cryptographic hash of previous block will go to the peers. Okay, now the important thing is in the transaction history, right, in the transaction records, this block will be added as it is. So this was the previous P1 and this is the current. It will be added as it is. So now this is the block chain of blocks. Okay, and this has T1, T2 and T3, and these are also linked with the each other. Okay, with the cryptographic hash values. Okay, now what your peer extra does is it updates the state db, right, and it also uh, place a bitmarks bitmark on each transaction, whether to indicate whether that transaction is valid or not. Okay, if the transaction is valid, then that will be the write set basically will be used to update the ledger state. Okay, so let's understand what all things your peer will do. So now your peer has block that has transaction T1, T2 and T3. Okay, your peer will take first transaction. Okay, and uh, because it will take the first transaction because it want to commit the commit this transaction. Okay, so as a part of before it commits the transaction in the state database, it has to perform couple of more steps. Okay, and what are those steps? First it validates uh, it validates if this transaction has endorsement or not. Okay, if this transaction does not have any endorsement, then it will be marked as marked with a validation flag 0 as 0. Okay, which means this is invalid transaction, but this transaction will not be deleted from this block because your ledgers are immutable data structure. Okay, once a transaction is added, it can never be deleted. Okay, so it will be marked as 0 because it does not have any endorsement. So if it does not have any endorsement, it cannot change the word state. or the state database values. Second, if it has a endorsement, so as a part of the validation, second it will what it do is it will validate. Sorry, some problem with my digital pen. Sorry, 1 second. Okay, so second, if it has endorsement, then it validates, your peer will validate if it has been endorsed by one of the one of the um, uh, block uh, channel peer or endorsing peer. Okay, say suppose if you add the signature of some XYZ person, that signature cannot be counted, right? So your peer validate if it has been endorsed by a valid endorser. Okay, and how it does this? It does this with the help of MSP. With the help of MSP. Okay, we'll see how we create the MSP and how we configure the MSP in the PA. Okay, so it validates if it has a valid MSP. I'm sorry, if it has valid signature of a valid endorser. Okay, with the help of MSP, right? So this is the second check. Okay, if that check is also passed, then the third check is endorsement of this transaction will be validated against the endorsing policy, right? Endorsing policy, we in the endorsing policy we can specify that who all endorsers should validate a transaction to consider that transaction as a valid transaction. Okay, so based on your based on the endorsement policy of this chain code, your peer will validate or determine if this is a valid transaction or not. This is a check number third three or four. Okay, so endorsement policy is also validated. Check number 5, right, which is very important. It it has a read set. Okay, in the read set you have said you in the read set, value of, say suppose something is like this in it. Okay, name of the key is init and version is 1, or say suppose version is 2. Okay, peer will validate. Okay, or it will try to determine. Okay, or it will actually check what is the current version of this key. In the result set, value of this key is 2. Okay, so that is good, right? Value of this init key is 2 in the result set, but what is the current value of this key in the in the state database? Okay, if it's still 2, right? If its value of version of this key is still 2, then it that read set will be considered as a valid and this transaction will be also considered as a valid. But if your peer finds any discrepancy, say suppose in the read set the version of this key is 2, but in the ledger some other transaction has updated this key and the current value of init is 4, then this transaction will be rejected. Okay, because this transaction will be rejected because this transaction was simulated against the old value. Okay, this is a very important point. Okay, but consider that that is not the case, and read set version of the keys in the read set is same as version in the state database currently. Then your peer will consider this transaction as a valid transaction, and then it will go ahead and it will commit this transaction. Okay, now when I'm saying that commit this transaction, it will use the write set. Okay, what does it mean when I'm saying that it will commit the transaction? When I'm saying that it will commit the transaction, it means it will use the write set. Okay, and the values of all the key values which is in the write set will become the values, current values in the state database. Okay, so in the write set, say suppose there was a value called a, and the value was 5. Okay, so there was a key called the a, and the value of that key was 5. Okay, so this value will be committed in the state database. Okay, so it will have a key called a, and the value will be 5. If that write set has uh, one more key called the b, right, and the value was 100. Okay, and the b key already exists in the ledger, then your peer will take this write set value and it will update the ledger or update the value of b with the 100. Okay, so this is read and write set. Okay, now I'm going to show you this read and write set actually in a practical example. Okay, okay, so this is my chain code, hello world chain code, and I updated it uh, just to demonstrate you how the read set and write set works. Okay, to actually show you read and write set. Okay, uh, because in the previous hello world example, there was nothing in the uh, init method, and in invoke method, I was just adding a value in the state database, right? So I had write set, but I did not had any read set. So just to demonstrate you people, what I did is I have added something in the ledger or in the database uh, in the init method, and then I read the same value, same key, right, in the invoke. Okay, so now when this invoke will be called, because I'm reading a value, okay, I'm reading a value from the ledger, this value, this key, right, and because I'm reading a key actually from the ledger, this key will become the part of your read set. Okay, and in the write set you will be the key that is passed in the transaction proposal. Okay, so let's run this, and once you see this with your eyes, you will have more confidence. Okay, I'm stopping the network and I will restart it again. Okay, so network is up. I will go here. First, I have to create a channel. Sometimes time out because uh, sometimes my virtual machine is really slow. Okay, so now let's join the. Let me join. Uh, Let my peers join the channel. Okay, so my both peers join the channel. Now I'm going to deploy chain code or updated chain code uh, on the both peers. Okay, so we deployed the chain code. Now I'm going to instantiate the chain code. And so when we instantiate the chain code, um, Fabric automatically calls the init method. Okay, when init method is called in my chain code, a key value is added in the ledger, right? Let me see if there is any error. Okay, I don't see any error here. Okay, perfect. Now I'm going to add some value to the ledger. Okay, so this is the code to add values in the ledger. But if you see here, I have updated this code to get the or to read the values of the read write set. Okay, so where's my code? Here it is. Okay, so this is where you can see uh, new channel dot send transaction proposal, and I'm sending this transaction proposal to only one peer, which is your peer and the peer is created like this. So it has only uh, 7051 port number, which means it's a organization 1 peer. Okay, so we send the transaction proposal. Okay, transaction proposal request in the send transaction proposal method. When we pass this and when system execute this, it basically sends the transaction proposal to the peers, all the peers that are in this collection object. Okay, in my case, because there is only one peer, so it will be sent to only one peer. Okay, and after simulation, your peer returns the transaction proposal response. So this is my transaction proposal response. Okay, now this you can see here, and you also understand now, because if you send the proposal, right, to multiple peers, you will receive uh, multiple responses, right, because one response from the one peer, right? So we have to use the iterator to iterate over or to iterate or to look into each response, right? So this is why I'm using the iterator or the for loop here, right? So this is here you can see one proposal response, right? And from that proposal response, I have get the object of the ns read write set info. Okay, I don't know what is the meaning of ns, but read write rw means read write set info. I got this iterator of this object, right? So response proposal that get dot get chain code action response read write set info, and then get uh, read read write set info, right? So we call this methods, we will get the iterator of the iterator that can iterate over read write sets. Okay, that has come in the um, what we call in the indoors transaction, right? So I use the iterator again, and then uh, 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 this iterator will give me individual objects of the read write set info, right? And then the read write set info dot uh, um, get read write set get read counts. Okay, so it tells me that how many reads lines or objects we have, and how many write objects we have. Okay, and then in the next statement, right, I have get the list of all the key value read, right? Key value, version, actually, not value. In case of the write, it will be key value, but in case of the read, it will be actually key version read object. And similarly, in case of the write, I have get the key value write object. Okay, list of the key value read objects and key value write objects. Okay, then in another for loop, we have read the individual uh, key version read and key value write objects. Okay, and then from that object, I have extracted the key and the version. And in case to get the right uh, values of the right set, we have used the key value write dot get value and get key. Okay, so if I run this program now, my program will send one transaction proposal. Okay, and this transaction proposal will be for the hello world chain code and the invoke function, right? And so in the invoke function in the chain code, you can see what we have. Now here is my invoke, right? So I'm reading something, and then I'm writing something, right? I'm retrieving something from the ledger, and then I'm updating the ledger. Okay, so I will have something for the in the read set and as well as in the write set. Right, in the read set I will have init with some version, and in the write set I will have key that I have passed, which is the first value. Okay, so let's try it. Let me run this, you will see. Okay, here it is. Read count 1, write count 1. Okay, so we have one read and one write. Okay, you can see here read key equals to init. Why it is init? Because this is the key that I'm reading, right, in my chain code method. Okay, and the version is 1. Got it? And then in the write set you can see I have key as first value, and the value is it's an hash code of an object. Okay, because I did not had lot of time, so I was not able to convert that object into a string object. So that is why you are seeing here uh, a written value of two string of that object. Okay, so but this is the key and this is the value. So key is the first value. Okay, so first value is in the read in first value is in the write set. Okay, and in the read set we have init. Okay, so this is all about the read set and the write set. Okay, and are the result of your transaction simulation. Okay, so that's it for today. Okay.